Hi scholars, Miss Beglin here with a voiceover of today and tomorrow's materials and expectations. As always, please make sure you are meeting the expectations for class, mask up, looking fly, and material expectations. You won't need your phone for these lessons. So let's keep going. Our agenda for today's classes, we have a quick announcement, and then I'm going to take you through our next aspect of Project 1 Task 1 Lesson 5, where resources come from. So I'm obviously not here. I will be out for the remainder of this week. Your task for today, February 2nd, and tomorrow, February 3rd, is to create a life cycle diagram of an item of your choosing, as we discussed in class yesterday on the 1st. Your analysis and diagram will be graded as an assessment, so please use this time wisely. Proceed through the following slides to get started. You may also find it helpful to use the video attached to this Google Classroom post to go through these slides, which if you're hearing my voice, that's where you are. And be well. So the goal for these days is that students will be able to complete life cycle analyses of a common item of their choice. As we've discussed, a life cycle diagram is a systems diagram that is used to analyze the environmental impacts of a product. So I am going to take you through a way to get started on researching your object's origins by taking you through the origins of a combination lock. So you're going to make use of this website called Made How. And you're going to scroll down to the alphabetized list, and I'm doing a combination lock, so I'm going to click C, and I'm going to scroll down to combination lock. The first thing I need to know is, what is a combination lock made out of? So I can scroll to raw materials. Please ignore my calendar. And I can read the raw materials section to see what a combination lock is made out of. And after doing that, I will learn that a combination lock has three main components: stainless steel, nylon, and Zamac. But what are these things? What are they actually made of? I can't dig in the ground or go to a tree and grab some stainless steel or some nylon or Zamac. So you're going to do some of your own research to figure out what your raw materials are made of. So I did a quick search on Google. What is stainless steel made of? And after reading this article, I came to the conclusion that it is made of chromium, nickel, nitrogen, and molybdenum. I repeated this process for nylon and Zamac. You'll notice I use the WiseGeek website as well as Wikipedia. These are good sources for you guys to use in your own research. And at the end of this, I have a list of truly raw materials that go into making a combination lock. This is way too much stuff to include in my life cycle analysis. So what I'm going to do is I'm going to choose 2 to 3 that I'm interested in to focus on. In this case, chromium and petroleum. So now let's talk about petroleum. How is petroleum sourced? Consider the energy, water, and materials used, the waste produced, human labor, transportation. We actually discussed how petroleum is produced and refined into a variety of products. So you can absolutely use class resources as a source. And then for chromium, how do we get chromium? Well, it's mined. And we also explored the impacts of mining, so you can absolutely use class resources to support your analysis here. Where does chromium actually come from? Well, if you go to the Wikipedia page for chromium and you go to occurrence, let's see, you can see that it's very prevalent in South Africa, Kazakhstan, India, Russia, and Turkey. So once we have a sense of where the base materials come from, we can talk about processing. And to do that, we'll go back to the How Made page. And we'll go to the section on the manufacturing process. And we'll read this. And as we read, we'll identify all of the inputs and outputs of this process from the website, including the materials, water, and energy used, and the waste produced. Then we have to talk about transportation of our finished product. It's obviously got to be transported to stores where it's sold. What are the inputs and outputs of transporting something? Again, we've talked about this in class, so you can use your class resources. Is transportation required anywhere else in this process? It absolutely is, to get the petroleum and the chromium to the manufacturing station. So you can also speak to that. And finally, we'll conclude with a brief discussion on product use or consumption. What are the impacts of using the product? How long is it typically used? Are any of the materials required to use it? Are there any other impacts of its use? And at the end of this research process, you should have everything you need to create a beautiful life cycle diagram detailing the life cycle of your object. So now it's your turn. You're going to complete a life cycle analysis of an item of your choosing by completing the life cycle analysis support sheet linked to this assignment on Google Classroom. So here's what that looks like. It basically walks you through the research steps, what you need to comment on, etc. And then once you've completed that support sheet, represent your analysis as a diagram. Remember, this will be graded as an assessment. So you have today and tomorrow to complete this assignment. Please use your time in class wisely. And please make sure you complete everything in the life cycle analysis support sheet. Hint, hint, hint. See you, scholars.